Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Oyun, Binti Ahamad Nazari. My matric number 12425.7. I representing for Group KSP. Today I will presenting step-by-step solution and financial evaluation for my Excel assignment covering two main real-world financial modeling problems. For question 1, designing a flexible home financing amortization schedule with multi-phase constraints and an early prepayment strategy for homeowners Amir and Sarah. So, for the first one, consists three distinct phases, which is repayment holiday, interest-only payment, and remaining phases. This question need to find monthly installment. So we go through the information question given. The question give the principal amount, which is 300,000 ringgit, 30 years loan terms, and the total of loan months. I calculate the loan term in years times 12 because in monthly, so times 12. So the question give effective rate per annum 4.5%. The monthly interest rate I calculate for J. J is 1 plus 4.5 to the power of 1 over 12 minus 1. So we got the monthly interest rate 0.3675%. So the next is interest on the period phase and for years. 3 years for the month, 36 months, and holiday phase duration 0.5 years, which is 6 months, half of the year. So next, we calculate balance at the end of the holiday duration, which is I calculate the principal amount times 1 plus monthly interest rate to the power of 6 months. So we got the balance at the end of holiday duration for 306,675 ringgit 72 cents. So next, I calculated the periodic monthly installment. So monthly installment, the balance at the end of the holiday times monthly interest rate over 1 minus 1 plus monthly interest rate to the power of negative loan months 360 minus the interest only period phase for 36 years, 30 months. So we got the monthly installment, which is 1,620 ringgit and 30 cents. If we change the loan terms in years, for example, from 30 years to 25, our Excel model automatically updates the total loan months dynamically. Since the holiday phase and interest-only phase durations remain fixed, changing the total loan term directly impacts the remaining amortization months in phase 3. As a result, the formula recalculates the required calculated period installment to ensure the principal is fully settled within the new time frame. So I need to change the original 30 years. So next, the second one, which is second one to construct the loan amortization schedule to show the financing arrangement. So the question given repayment capital for 10% and frequency for 12 months every month starting year 2 for extra repayment, and specific start month is first month. So schedule unit is we can change months to year. Okay, so months, the ending period is after we calculate the amortization schedule. So ending period, I got 146 months of 146. Okay, so we move the loan amortization schedule. So I need number of months, beginning balance, payment amount, extra repayment, interest paid, principal paid, and outstanding loan balance. So the first one, beginning balance, we extract the outstanding loan balance before and put the first month, and I drag this cell drag down until 360 years. Next is payment amount. As shown in the loan schedule, from month 1 to month 6, the payment amount is recorded as 0. This represents the repayment holiday phase where the borrower is granted a 6 month period with no monthly installment required. However, the interest still accrues every month. Because zero payment is made, the accrued interest is added back to the principal, causing the outstanding balance to increase from 300,000 ringgit to 306,675 ringgit 72 cents by month 6. Okay, so we go to the extra repayment. Moving to the extra repayment column, according to the agreement terms, Amir and Sarah are allowed to make an extra repayment at the beginning of each year, starting from year 2. To pay off their debt as fast as possible, they maximize this to the maximum allowed limit of 10%. As you can see in month 13, for month 13, the extra repayment is calculated as 10% of the beginning balance, which equals 30,667 ringgit 57 cents. This extra payment goes 100% directly towards reducing the principal balance. Consequently, the balance drops instantly from this to this, which significantly lowers the monthly interest charged in the following months. So for the interest paid, the monthly interest is calculated using the formula interest paid equals to beginning balance times monthly interest rate. So I drag this cell drag down until 360 months. So during phase one, from first month until 6, because no payment is made, the interest accumulates each month and compounds into the principal balance, causing the interest charge to slightly increase every month up to 1,122 ringgit 85 cents. So during phase 2, from 7 until 36, since Ami and Sarah pay only the interest of 1,126 ringgit 97 cents. Yes, from this per month, the principal remains flat at this, because making the monthly interest charge constant throughout this phase. After extra repayments from month 14 onwards, notice how in month 13, after making a 10% extra repayment, the loan balance drops to 276,008 ringgit 14 cents. Consequently, the interest charge in month 14 instantly dropped from this to this, saving their money on interest every single month moving forward. So we go to the next. The next column is principal paid. In general, the monthly principal paid is calculated as payment amount plus extra repayment minus interest paid. Okay. During phase 1, since the payment is zero, the formula gives a negative value. Because meaning the zero principal is settled, and accrued interest gets added directly to the principal balance. During phase 2, months 7 until 36, since the payment covers only the interest charge, principal paid is exactly 0 ringgit. The borrower pays 0 towards reducing the original debt balance. When extra repayment occurs, for example, for month 13, the lump sum payment goes 100% into principal paid, directly reducing the loan balance. During phase 3, month 37 and onwards, the regular monthly payment of 1,000 payment amount this kicks in. Now part of the payment covers interest and the remaining portion goes towards principal paid continuously. shrinking the debt balance every single month until it reached RM0. And for the last one is outstanding balance. So finally, this column shows the exact remaining debt owed at the end of each month. It is calculated using the formula the beginning balance minus the principal paid. And I drag down until the 360 months. So because of the 10% annual extra prepayments, this balance steadily decreases until it hits RM0 in month 146. Yes, 1146. So this is RM0 in month 146, marking the complete settlement of the loan. So the third Roman is to evaluate and find the minimum possible financing term that can be achieved through these strategies. So to minimize the financing period, Amit and Sarah make the maximum extra repayment allowed under the financing agreement, which is 10% of the outstanding balance at the beginning of each year, starting from year 2. This monthly payment structure remains unchanged according to the requirement based on the amortization schedule. The loan is fully repaid in month 146, equivalent to 12 years and 2 months. Compared with the original tenure of 30 years, 360 months, the financing period is reduced by 214 months, equals to 17 years and 10 months. This allows Amir and Sarah to settle their debt much earlier while reducing the total interest paid. So, finish for the question 1. Next, let's go to the question 2. For the question 2, calculate the IRR for both Project Seri and Project Bakabali. So the question has established an internal target for the rate of return at 4.5% effective per annum for its investment. So the question have given the cash flow for Project Seri and Project Bakabali from year 1 until 25, until year 25. So the question need to find IRR. So we need to find the present value first. So the present value, I calculate the cash flow over the 1 plus 4.5% to the power of year. And then I drag down until year 25. Same goes to the Bakabali. So next, internal rate of return. The IRR represents the expected annual rate of return generated by an investment. Mathematically, it is the exact discount rate that makes the net present value of all future cash flows equal to 0. So for project Seri, I got 9.18% and Project Bakabali 9.64%. Both of since both Project Seri and Project Bakabali is exceed the target rate of return 4.5%, so the both projects are acceptable from an IRR perspective because they are expected to earn more than our required rate of return. So I use I add on the column as an object. If the IRR for Seri exceed the 4.5, it is accept. If not, it reject. Same goes to Project Bakabali. Okay, so the next question is to find net present value. Yeah. So MVV measures the total net financial value created by an investment today after discounting all future cash inflows and outflows back to their present value using our target discount rate of 4.5%. So to calculate cumulative present value, so I calculate some of this cumulative value from the previous year plus present value for year 2. So we got this and I drag down until 25. Until year 25. Same goes to Project Bakabali. And then, so Project Seri net present value is higher than Project Bakabali. So, since both projects have positive MPV, both are so since project MPV for Project Seri and Project Bakabali is exceed the 0, both are profitable and financially acceptable. So we go to the next question for searching on payback period. So the payback period measures the total amount of time required for an investment to generate enough cumulative discounted cash flows to recover its initial outlay. In short, it tells us how fast the company gets its money back. The cumulative present value is used to determine discounted payback period. When the negative for project series for year 16, we identify the negative value this, and the next year is positive. Um, and then for the bakar bali, I identify the year 13 is negative and for next year is positive. So these values are then used to calculate the exact discounted payback period. Project Seri has a payback period of 16.16 years and Project Bakabadi is 13.40 years. So, Project Bakabadi recovers its initial capital faster by approximately 2.76 years compared to Project Seri. For the last question is, based on my answers in first Roman, second Roman, and third Roman, which project should the corporation choose? Explain why. So, the answer is both projects are acceptable because their IRRs are higher than the company's target return of 4.5% and both have positive NPVs. However, the corporation should choose Project Sri because it has the highest NPV of 498,370 ringgit and 64 cents compared to Project Pakabali. A higher NPV indicates that the project is expected to generate more net value for the company after considering the time value of money. Although Project Bakabali offers a slightly higher IRR and a shorter payback period, Project Seri produces the greater overall financial benefit and therefore is the preferred investment option. So, thank you.